Alright, limiting to reactants. A limiting reactant is an ingredient that controls how much you can make. The excess reactants are the things that are left over or unused. So we have another example here with making s'mores. Say you have a s'more. It takes 2 graham crackers, 1 marshmallow, and 1 piece of chocolate. According to the diagram at the bottom, how many s'mores can we make? And if we look down there, we got 5 marshmallows, 3 chocolates, and 5 graham crackers. Remember, we need 2 graham crackers, 1 marshmallow, and 3 pieces of chocolate.
1 piece.
I'm sorry, I said 1 piece of chocolate for each s'more. Okay, so using this, we need 2 graham crackers for each s'more, and we have 5 right there. So we can only make 2 s'mores from the amount of graham crackers we have. So the graham crackers are going to limit how many s'mores we can make. So this graham cracker would be the limiting reactant.
So we end up using 2 chocolates total and 2 marshmallows. So the stuff left over is we have 3 marshmallows left over, we have 1 chocolate, and only 1 graham cracker. What you have left over whatever limits you can in cooking, still have stuff left over, you just don't use it, but in chemistry you'll use all of the limiting reactant. And so while you finish writing all that down, we're going to enjoy our s'mores. On to the chemistry. Okay, so here, when you have a limiting reactant problem, it's just stoichiometry times 2 or more, depending on what questions we ask. So in this problem, you see that we have, back on my pen, 20 grams of sulfuric acid is added to 230 grams of barium peroxide. So the first step we have to do is write the balanced chemical equation. Have we not the page now? We're learning new things. I can just hit page instead of next. Okay, so this is our balanced chemical equation. We have 120 grams of sulfuric acid. We have 180 grams of barium peroxide. And this thing asks a lot of questions. I want to know what is in excess and by how much. We're going to get to that last. And I also want to know how much barium sulfate is going to be produced. So you end up having to take your 120 grams of sulfuric acid, you'll solve for your barium sulfate, take your 180 grams and solve for barium sulfate. When you're doing these, you want to solve for the same thing so you can compare it. So you can see I put down so y'all can write that. And so here are the 2 problems.
And as you can see, the 120 grams of sulfuric acid produces 285.56 grams of barium sulfates, while the 180 grams of barium oxide produces 248.1 grams of barium sulfate. Thus, the amount that's going to be produced is going to be the lower amount, the 248.1 grams of barium sulfate. That's all that can be made from the 180 gram. Thus, that one is the limiting reactant, and the other one's in excess. So whichever one produces the least amount is the limiting reactant.
Okay, and then the other thing I wanted to find out is how much of that excess are we going to have left over? Maybe we want to make sure that we're using it all up completely, and we'll just have to add more barium peroxide. You can't just take the difference between the 2 things produced. No, you cannot do that difference. You have to look at how much you started with and figure out how much is left over. So in this case, you get to do stoichiometry one more time to find out how much sulfuric acid is needed to react with its 180 grams. So we've got a new question mark over here.
Alright, so here we go. We got 180 grams of barium oxide. We do all the stoichiometry, and we're going to use up 104.26 grams of sulfuric acid. But remember, we started with 120 grams. So we started with 120 grams, but we only used 104.26. So we're going to have left over 15.47 grams. We'll dyslexic there.
Yes. All right. That's limiting reactants in a nutshell. We'll see you in class with lots of practice problems.